Okay, so I need to finish the section on molar concentration. So this is section 3.6, ions in solution, on page 139. So I'm going to share my screen. And we're going to take a look down here. And remember that ionic compounds are made up of a cation and an anion. They're neutral when they're together. However, if I put something like that into water, ionic compounds tend to dissolve, okay? And when they dissolve, we say they disassociate. And the ions are going to travel independently through the solution. So if I have something like aluminum sulfate, solid, and I put that into water, you're going to end up forming 2 aluminum ions and 3 sulfate ions in solution, as they've shown you here. So the AQ that is after each one of them is telling you that these are moving around in solution, okay? And if you take a look at the next page, if you're given the concentration of ions or of a solution, you can calculate the concentration of their ions. So when they ask you in a sample problem, what concentrations of ions are present in 3 molar calcium chloride? So calcium chloride is going to disassociate into a calcium ion and 2 chloride ions because there's a little subscript 2 there on the chloride. So if they give you the concentration of the solution, this is 3 molar. If I only have 1 calcium ion forming, then that concentration is 3 molar. It will be identical to the concentration of the solution that I was given. But if there's a coefficient other than 1 in front of the ion, you have to multiply that coefficient by the solution concentration, which will give you 6 molar for the concentration of the chloride ions. Okay? Now, sometimes they like to represent molar concentration of a substance by putting square brackets around the chemical formula. So if you ever see square brackets around something, what that means is the molar concentration of the substance that is inside of it. So that would mean the molar concentration of the sodium ions, okay? So if you see something like 2 molar sodium ions or in brackets equals 2 molar, that's what that is implying to you. We don't write 2 molar and then sodium ion in brackets. It's kind of considered redundant. Okay, so what we're going to do is we're going to come down here to the practice problem where they ask us for the concentration of ions in 1.5 molar calcium chloride. And so if you take your calcium chloride and you write it disassociating, we have a calcium ion, and I know that that's a +2 charge because if you use your periodic table with all the nomenclature notes on it, trying to get mine out here, okay, you want to use this one. Calcium has a charge of +2. Chloride ions have a charge of -1. So we're going to form 2 chloride ions at a -1 because there's a 2 there, okay? This concentration is 1.5 molar. So since I'm forming 1 calcium ion, its concentration is also 1.5 molar. But since there's a coefficient in front of the chloride of 2, take 2 times this 1.5, which is going to give you 3 molar. So if you wanted to write it as the calcium ion concentration equals 1.5 molar, you can. And then the chloride ion concentration equals 3 molar. Okay?